To discuss valves. A valve is a device which stops or regulates the flow of something, usually a fluid such as water or oil, or a gas such as air or steam. But valves are also used with solids such as sugar or flour. There are many different styles of valves, and we will discuss the functions and designs as well as the advantages of the more common ones. First, there's the plug valve. One of the first recorded uses of this type valve was by the ancient Romans in their water distribution systems. Plug valves may have any one of several different designs, but they are all basically the same in that they have a round plug with a hole through it, like this. The hole is usually oval or rectangular and with rounded corners. This plug is then inserted in a round hole in the body, which fits it closely. The plug may be either tapered like this, or it may be straight. The body, of course, corresponds to the plug and also has a hole at either side. By turning the handle a quarter turn, it goes from full open to completely closed. Plug valves are relatively economical, but are used primarily in situations requiring full-on or full-off operations. They are not normally used in applications which require frequent operation, since the metal-to-metal contact tends to cause faster wear than in certain other styles of valves. However, lubricated plugs tend to overcome this problem. There's very little pressure drop in the plug valve. Pressure drop is a term to remember, since it's commonly used when referring to a valve's operation. It is the loss in pressure between any 2 points in a system. In this case, between the inlet here and the outlet here. It is a result of the friction between the material being handled and the valve which it comes in contact with. While we're covering common terms in the valve field, another term to discuss is water hammer. Now, water hammer is when we take water and freeze it onto a stick like this. Then we have a water hammer. No, I'm only kidding. Water hammer is actually the term applied to shock, resultant noise, and pressure buildup caused by closing a valve very quickly. It's caused by the energy of a mass of moving fluid which is suddenly stopped. And care should be used when operating plug valves or others such as ball or butterfly, which can be rapidly closed, to make sure that we don't cause damage to the system with water hammer. We will explain ball valves and butterfly valves in a few minutes. Common plug valves come in 2 styles. The lubricated like this, and non-lubricated like this. The non-lubricated plugs, especially in the smaller sizes, are also called plug cocks. For example, a steam cock is just a small, non-lubricated plug valve used for steam. Lubricated plug valves use some type of material like heavy grease or plastic, which is not affected by the material being handled by the valve. This lubricant is forced under high pressure through grooves like these. This pressure tends to lift the plug off its seat and make it easier to operate. Gate valves, as the name implies, use a gate, this piece right here, which is slipped into a slot of similar shape, or valve seat as it's called. Since the gate is moved completely out of the path of flow when the valve is all the way open, the gate valve has less pressure drop than most other type valves. This, together with its relatively trouble-free service, accounts for its wide acceptance throughout the industry. The gate or wedge may be one piece, like this, which is known as a solid or a single wedge, or it may be in 2 interlocking halves, in which case it is called a split or double wedge. The closure is accomplished by metal-to-metal contact between the surface here on the gate, or disc, and the surface here on the seats, both of which have been ground to give a smooth finish. These mating surfaces may or may not be hardened, depending upon the service for which they are intended. Gate valves are furnished with rising stems like this, where the stem rises up out of the valve and brings the gate with it as it comes. Or with non-rising stems, where the worm on the valve stem screws down through the gate and thus the stem stays in position while the gate rides up as the worm is turned. One advantage of a rising stem is that a person can tell at a glance by the position of the stem whether the valve is open or closed. This one is open, and this one is closed. As compared to some other valve types, the gate valve is slow in operation, since the hand wheel must be turned several times in order to open or close it. Gate valves are not recommended for throttling. Throttling is a term used when we use a valve to reduce either flow or pressure or both, but still allow some flow through the valve. Quick opening gate valves, like this one, are used in certain applications where speed of operations is of prime consideration. They take a relatively large force to open or close them. Next, let's discuss globe valves. Globe valves are quite common and are widely used for throttling applications. They're built like this, with a circular disc which closes against the seat right here. The seat is normally ground metal, while the disc may be ground metal or any of several non-metallic materials. The non-metallic discs are replaceable, which is an advantage since many throttling applications tend to cut them out. Most faucets around the home are a type of replaceable disc globe valve. This is a disc, or faucet washer as it's called, right here. Globe valves, because of their internal design, have a lot of friction surface and cause a lot of turbulence, as you see by this flow pattern here. As a consequence, they have a relatively large pressure drop. Like the gate valve, it is slow in operation since several turns are required to open or close it. Most globe valves are inline style, like this, but they are also available in the right angle pattern, like this. An angle globe can frequently be used instead of a regular globe, plus an elbow, and this makes for less pressure drop, as well as a more economical installation. The common household faucet is a right angle type globe valve. Needle valves could be called a type of globe valve since the internal flow pattern is essentially the same. The difference here is that instead of a disc which closes on the seat, we have a needle which protrudes through the seat area so that the closure is here on the sides of the needle. The needle valve is designed primarily for throttling applications where very accurate control is desired. Normally, several turns of the handle are required to change the flow very much. Since the port openings here are very small, the pressure drop across the needle valve is quite high. Port opening means the size of the opening at the seat of the valve, this area right here. Because of this small port, needle valves are a poor choice if any great amount of flow is required. The ball valve is very similar in operation to the plug valve, in that a 1/4 turn will move it from full open to full closed. This is open, and this is closed. The position of the handle clearly indicates whether the valve is open or closed. Ball valves are excellent for most off-on service, but are not recommended for throttling applications. With the ball valve, a sphere or ball is used instead of a plug, and the closure is accomplished by a resilient seat here, which is usually some type of rubber or Teflon. Resilient means something which can be deformed or pressed out of shape and which will return to its original form once the pressure has been removed. Teflon is a synthetic plastic material widely used in home and industry. You've probably seen it used to coat the inside of skillets. The ball in a ball valve has a round hole through it and may be either full port or reduced port. Full port means the hole is as large as the nominal valve size. That is, a 2-inch valve has a 2-inch hole. Reduced port means that the port opening is smaller than the valve size, like this. In recent years, ball valves have been widely accepted in industry, and many manufacturers now make them. Butterfly valves are yet another type of valve which goes from full open to full closed with 1/4 turn of the handle. No, they don't look like this. Actually, they have a disc or butterfly like this, which is enclosed usually by a resilient ring. When it's turned like this, It closes the opening. Because of the simplicity of design, this valve is very economical in initial cost, but it normally is not used in applications which are operated frequently, since the wiping action of the butterfly as it closes causes relatively rapid wear. Plug valves, ball valves, and butterfly valves in the larger sizes are hard to open and close with just a straight handle, so they are usually equipped with some type of operator, either manual or automatic. Most of the valves mentioned so far, with the exception of the plug valve, have stems which are exposed to the material flowing through the valve. This means that some type of seal must be provided to prevent leakage around the stem, and there are several different types used. For example, here is an O-ring. An O-ring is a little donut-shaped ring of some resilient material, usually rubber. This O-ring fits into a groove and seals against the stem. One of the more common seals is a stuffing box. With this type seal, some material is placed into this area, or box as it's called, and this follower or gland is forced around the stem, hence the name stuffing box. Many different materials are used for stuffing box packing, depending upon what is being handled by the valve. One of the more common is graphited string, which is string which has been impregnated with graphite. Graphite is a form of carbon and is a dry lubricant. Another common stem packing is Teflon, which may be either molded to fit the stem or in string form. One of the chief advantages of a stuffing box is that if it starts leaking, simply tightening down on the packing gland will usually stop it. The diaphragm valve uses a sheet of flexible material, usually some type of rubber or resilient synthetic material, which may or may not be reinforced with fiber. This sheet is bolted in place right here between the cap and the body of the valve. The valve stem is connected to one side of the diaphragm, and that side is never exposed to the medium flowing, and therefore no stem packing is required. Because only the bottom half of the body and the bottom side of the diaphragm ever come in contact with the material being handled, this valve lends itself to handling many relatively hard-to-control materials, such as a caustic or acids. As you can see, when the stem is screwed down, the diaphragm seats here to close the valve. There's another style of valve which is operated by much the same type action that is used when we squeeze the garden hose together like this to stop the flow of water. Several different mechanisms are used to clamp together what is essentially a section of hose. Since nothing except the inside of the hose is exposed to the material being handled, this valve is especially good in handling abrasive materials such as sand and water slurries. Okay, up till now, we've shown only valves with handles or hand wheels. Now we will discuss how valves may be operated other than manually. There are about as many different types of operators for valves as there are valves. One type of electrical operation is with an electrical solenoid. Solenoid valves are usually either globe or needle valves with a solenoid actuator. But in this case, the whole unit, valve and all, is usually identified as being simply a solenoid valve. If an electric motor is used as an actuator, the valve is usually identified as a motorized valve. In this case, a motorized ball valve. Here, a small motor with built-in speed reducer develops the necessary torque or twisting force to operate the valve. Pneumatic actuators are those which use air pressure to operate them. They may be cylinders which act directly, or the cylinders may in turn operate a rack or slide arm of some type to accomplish the closure. Diaphragms, this part right here, and bellows, this right here, are used with air to accomplish the same result, that is, an in and out motion as is achieved with the solenoid. Frequently, a combination of electrical and air is used. For example, an electrical solenoid valve opens an air line, which then supplies air to an air actuator. Sometimes the pressure of the material being handled is used as the motivating force. For example, water, which is being controlled, may be used as the force to operate a cylinder, which in turn operates a valve. Frequently, in a piping system, we desire to allow free flow in one direction, but to stop flow in the other. This is accomplished with what we call a check valve. The most common is the swing check, where we have a hinged flapper or disc which is moved up and out of the way by the pressure of the flow against it. When the flow is reversed, the flapper seats and is held in place by the back pressure on what is normally the outlet or downstream side. If there are frequent reversals, then a lift check is usually recommended. They operate essentially the same as the swing check in that in direction of normal flow, the disc here lifts up and allows flow, but it seats when flow in the opposite direction is attempted. Ball checks operate exactly like lift checks, except a ball here is used instead of the disc. Pressure relief valves are essentially angle globe valves, which instead of having a worm and a handle to open and close them, have a spring on top of the disc to hold it on the seat. The pressure is on the underneath side of the disc, here in red, and pushes the spring. When the pressure here on this side becomes more than the pressure supplied by the spring, the disc lifts and relieves the pressure. Since the tension on the spring can be adjusted, the valve can be set to operate at some predetermined setting and thus prevent the pressure from becoming high enough to do damage to the rest of the system. Okay, so far we haven't discussed the materials from which valves are made. Usually this is determined by the service the valve is to be used in. Bronze or brass are widely used for water service because they won't rust. Cast iron is widely used, particularly in the larger size valves. Cast steel and ductile iron are frequently employed, especially for higher pressures. Stainless steel also finds wide use, usually for handling corrosive materials. Several varieties of plastics have been used, and the chemical industry even has glass valves. Any type valve, that is gate, globe, ball, plug, etc., has at one time or the other been made from any one of the above-mentioned materials. Okay, now finally, how are valves installed in the line? Well, first, there's the screwed connection, where there are female threads in the valve which mate with the male threads on the pipe. Threaded or screwed valves are normally available in pipe sizes 1/8 inch through 3 inches, but larger sizes are available on special order. Flanged connections are commonly used on larger size valves. In this case, a flange is either welded or screwed onto the pipe, and this flange is then bolted to the flange on the valve face. Normally, a gasket to serve as a seal is put in between the flanges before they are bolted together. Butt welding valves are used in a number of installations, especially for high-pressure installations and usually in larger sizes. These are machined with a weld groove on each end ready to weld into place. Care must be used in the welding process so that the valve doesn't get so hot that there's a possibility of warping. The only way a welded valve may be removed is to cut the pipe. Okay, now let's briefly run back over our valves. Gate and globe valves are probably the most common. Gates have little pressure drop but are not recommended for throttling. Globes are used for throttling but have a high pressure drop. Ball, butterfly, and plug valves go from full open to full closed with a 1/4 turn, but the handle and this quick closing may cause water hammer. They have small pressure drop. Needle valves are designed primarily for throttling, but because of small port size, have high pressure drop and can't handle much flow. Diaphragm valves are especially good for hard-to-handle materials. This is also true with clamped hose valves because the material never comes in contact with the valve stem. Check valves allow flow in one direction only. Relief valves are spring-loaded valves which relieve excess pressure in a system. This concludes our discussion on valves. I'm Dave Brown for Tel-A-Train.